Alright, so in this video, I'm going to solve the equation x to the power of 3 is equal to phi to the power of 3. So to solve this, I'm going to first subtract phi to the power of 3 on both sides. So I get x to the power of 3 minus phi to the power of 3 is equal to 0. Now the reason I did this is so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this means that x to the power of 3 minus phi to the power of 3 is equal to x minus 5 times x squared plus 5x plus 5 squared. So now I get x minus 5 times x squared plus 5x plus 25 is equal to 0. Now this gives me two equations. I get x minus 5 is equal to 0, and x squared plus 5x plus 25 is equal to 0. So let's first start with the simpler equation, which is x minus 5 equals 0. All I have to do is add 5 on both sides, and I get x is equal to 5. So this is one solution. And now to solve x squared plus 5x plus 25 equals 0, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this turns into negative 5 plus or minus the square root of 25 minus 4 times 1 times 25 all over 2, which is equal to negative 5 plus or minus the square root of 25 minus 100 over 2. And this is equal to negative 5 plus or minus the square root of negative 75 over 2. Now, because we're dealing with the square root of a negative number, this means that this is going to be an imaginary solution. So, the square root of negative 75 is the same thing as the square root of 75 times the square root of negative 1. So let's first start by simplifying the square root of 75. The square root of 75 is the same thing as the square root of 15 times 5, which is the same thing as the square root of 25 times 3, which is equal to the square root of 25 times the square root of 3, which is equal to 5 root 3. And the square root of negative 1, if you guys already know, is equal to the imaginary number I. So I get x is equal to negative 5 plus or minus 5 root 3i over 2. So these are two more imaginary solutions to my equation.